Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video right now is day 15 of the 2021 Advent of Code. This is part 2 of the Chiton problem, and my code sucks. I'll just admit that up front, but I knew that going in. I just thought I could kind of get away with it, and I kind of can. I've got enough done here to get an answer. How long have we been going here? About a little over an hour. I promise you I do get an answer. I do for part 2 here, and I do get the correct answer. The correct answer, where is it? Oh no, come on. There, nope. Oh no. There isn't. I promise you my code sucks, but I get an answer. Where is it? There it is. 2821 is my answer. I'm just checking to see how long it goes. I did have it running. I left for some things. I had to do some errands today. It took under 2 hours, so at some point in the next, within the next 50 minutes or so, and probably by the time I finish making this video, because I plan on making this faster now that I have it working, but I just wanted to show you the process, right? That you start out with what you know, and then you just start working incrementally toward trying to find a better solution, and at some point, you can't find a better one. But that doesn't mean that you stop trying. There's got to be a way to prove that you can't get any faster, and well, this one definitely can, because I've done it faster many other times when I didn't shoehorn myself into an algorithm just trying to think, oh, it'll be good enough. Like, no, this is not good enough. Nobody wants to wait 2 hours for one game frame for a video game, right? Because that's think about like pathfinding. If you had a character that needed to get from point A to point B, do you want to wait 2 hours to figure out? Do you want to wait 2 hours for it to figure out where it needs to go? No, you don't. That's absolutely true. So the only difference between part 1 and part 2, at least when it comes to my first pass at this, is that the way that the data gets put into the from file into the list of lists. So according to the problem, I have to take the original grid and then shift it off 5 times horizontally and 5 times vertically, and that's what this thing does. And again, not even proud of this. It's just a busy day here for me. It's one of those, sometimes you have time to sit down and learn and get things done, and sometimes you just got to get crap done, right? And that's what I'm doing today. I got an answer. Moving on, and I thought this was going to be similar to day 12, and especially when they talk about pathfinding, find a path. Like, they don't even care about the path. They just tell you, tell me the shortest risk, tell me the smallest risk value in any path. But they don't care about the paths. So I think that's what I'm going to do here, is kind of eliminate the closed list, because there's no reason for me to keep it. Because I just figured part 2, because you never know what's going to happen after you finish part 1. So I'm like, well, they're going to want a path some point, right? Nope. They just want the values. So if I eliminate all of that checks, that's got to be quite a bit of the work. And so I look forward here, as soon as this finishes up, I look forward to challenging this and seeing how much faster I can get this down to, because I know I can get it under an hour. That I can guarantee. How much more than an hour, I don't know. So, but anyway, so that's all there was to it. Was I get the data itself just the same, and now I spread it out horizontally, and then each time I have to make sure I add 1 to every value, and then cycle around if I get to 10, and then do that vertically. What you can do here is just kind of take every row and just go, hey, like every row in this thing, go, what was 10 rows prior, and then go, well, how about I just add 1 to that and throw it in? And that's what this does. And again, excuse me, excuse me, please. That it's just the same kind of idea, that you just have to make sure if you go into double digits, you wrap around to 1, which makes it a little different, because most times you would wrap it around to 0. But again, I will show you proof here, because I learned now about just when things take long, I'm going to go, how long did it take? Well, now I can absolutely show it for sure, instead of just going, well, it took less than 2 hours. That's what I could say before. And in a couple minutes, hopefully, I'll be able to say how long it took for reals. All right, so just to say real quick before I get to the next part, the final part, before I move on with my life, is that it took 80 minutes. So 1 hour and 20 minutes it took to figure out the path from point A to point B And the best path was 2,821 units, like I told you. At least that was my solution, my data set. Maybe you had different values. So now I'm looking forward to seeing how much I can improve 80 minutes into. And let's go. All right, so I am done going down the rabbit hole for this problem. And so when I set everything up, part of the problem was saying that, like why would you have a pathfinding algorithm that doesn't require you to maintain the path? And that's what this problem is, because it doesn't care where the path is. And so what I did after all of this was eliminate all the copying of all of the path data, like as I'm going from possible path, potential path to potential path, adding another node to the path. Like, don't care about that anymore. And lo and behold, I got myself from 80 minutes down to about 3 minutes and 15 seconds. It should be going off in about 30 seconds or so, or maybe even more, because I did tinker with it just a slight bit more here. Or maybe I didn't. Maybe I made it worse. I don't know. But so far, we should be, judging off what I did here, that's 3 minutes and 15 seconds. So we got ourselves about 10 seconds before this thing's going to kick off, if everything else holds. And of course, it's never going to be exactly perfect, but compared to the other. But come on, let's do it. 5, 4, 3, 2. There it is. And so, yeah, this is useless. I just figured this is useless at the end of the day, but that's fine. So yeah, this is still ridiculously slow. 3 minutes and 15 seconds. You should be able to do this in seconds, if no more than maybe 5 to 10 seconds, maybe even faster than that. Again, coming back to just the way gaming works and all the A-star pathfinding I've done in the past, this should not be so hard, but it just is what it is. Or maybe it is supposed to take 5 or 10 seconds. I don't know. I wish I knew exactly what the best would be, but I don't know. Maybe you do. So please post below. Let's see, other things I could do to this. I could probably reduce a lot. Like I said, I'm doing a lot of deep copies on this thing. And at this point, I probably say, like, all the things I can improve. Well, I got rid of the closed list. I moved my endpoint out of this, so I'm not copying it incessantly over and over and over again. What else am I doing here? Path and maybe the list of lists. There's a few. Maybe there's a little tinkering. And again, what probably is taking a lot of this right now is all of the sorting. It probably is not sorting as well as it could. I mean, just I don't know, because just sorting. You're adding 4 points to a list and then you're resorting the entire thing. Other people have said use a priority queue or things like that, where maybe it's more efficient at sorting. But as this is right now, it's 4 o'clock in the afternoon. I put more time thinking in this, but it's a fun thought experiment. And if this is just day 15, they're probably going to hit us with this again another time in the next 10 days. So I am calling it quits on this problem. You can call it whatever you want, but I do have an answer, and I do have a way to get you an answer in a couple of minutes' time. And that's all there is to it. So thanks for sticking it out with me. Thanks for going through my craziness, hearing me out so far on a day-to-day basis as I slowly descend into madness. And I get to do it again in 7 hours. So take care, everybody. See you next time. Have a great day.